Hello everyone, welcome to my YouTube channel Cbse Courses with Reeti. As we discussed in the previous video about what exactly a carbon is, what kind of compounds do carbon form. In this particular video, we are going to understand more about carbon, its compounds, obviously as the chapter name suggests. So before starting the video, if you are liking my class 10 videos, so do like, subscribe and share it with your friends. Also, if any feedback or question related to the chapters, you can comment me below. Okay. Allotropism. Allotropism is basically a property of an element. Here, I have used the term element, though in this chapter, we are going to see the allotropes of carbon. Okay. Let us first understand what allotropism is. Okay, just a second. Let me get my duster here, and yeah. It's a property of an element to be present in two or more different physical properties but similar chemical properties. Now, होता ये है that one element is present in different properties, like different physical properties they have. Some is circle, some is like a football, some is hexagon. Let me just tell you with the example, but this definition is quite important. They are, it's a property of an element to be present in two or more different physical property. Means their physical property is different, their melting point, their boiling point, their structure, everything is different, but they have similar chemical properties. They have similar chemical properties obviously because if I take the example of carbon itself, if they are allotropes of carbon, may they have different physical properties. We'll look into that particular point, but obviously they will have same chemical properties because they are made up of carbon only. अगर कार्बन कितना चेंज होगा है तो basis are the carbon only, right? So it will have the similar chemical properties. Now, in our class, in 10th class, we have 3 allotropes. Allotropes are basically the element which are of the, you can say, different physical property but similar chemical properties of element is known as allotropes. Okay. First is diamond. Let me just draw the bullets here. I think this much is quite enough. Diamond, as soon as I say diamond, what does it come in your mind? Okay, it might be luster, it might be the beautiful jewelry made of diamond, but let us dig into chemistry. Diamond is the hardest substance. It's lustrous. Obviously, it's an allotrope of carbon. Hardest substance, lustrous, allotrope of carbon, and doesn't conduct electricity. Now you might think that मैंने तो इसके बारे में बस लिख दिया. What I'm actually talking about. Diamond is an allotrope of carbon, means carbon से बना है. It's lustrous, it's a physical state of carbon. It's a physical property of diamond. It's hardest substance. It's so hard that even to cut a diamond is used. A diamond is used for the surgery of cataract to remove the blurry layer. So you can just understand that it's the most hardest substance on the planet Earth by now, till now. Okay, it doesn't conduct electricity. I'm going to tell you about it and what I'm trying to say here. First, let me tell you it carbon, let me just write, I am just denoting C for carbon. Carbon in diamond is joined forming tetra. Just a second, let me just get the right spelling. Tetrahedral. Tetrahedral. Now you will see what is tetrahedral again. Tetra means 4 and it's forming a structure with the help of 4. Let me just try to draw it here. One carbon has 4 valencies. So it joins all its 4 valencies with carbon, then again with carbon, then again with carbon, and it forms something like this. Okay, sorry for the bad drawing. Means it forms something like tetrahedral. Each carbon valency is completed with a carbon only. It means all electrons are shared. All electrons are shared. It means that therefore no electrons for conducting electricity. Okay, I think it went a mess in bit. So I'm just gonna recalculate whatever I have said it in a better way. Diamond is the hardest substance. I gave you a few examples like the surgery of cataract with the help of diamond, and so it is obviously lustrous, something very favorite of each one of us, used in making beautiful jewelries. It's an allotrope of carbon, means it is made up of carbon. Okay, and it doesn't conduct electricity. If you have a diver, you can just place it and do the experiment. It will not conduct electricity. Now, a very important topic, a word that I think is mentioned in your NCRT textbook also, is that carbon in diamond is joined forming a tetrahedral structure. Tetrahedral structure. What do I mean by tetrahedral structure? Let me tell you. Tetra means 4, means each carbon valency, each carbon electron is joined with a carbon. Like one carbon have 4 electrons to be shared, and all the 4 electrons are shared with carbon only, and they form something like this. You can refer to your NCRT textbook for a clear diagram. Now in this case, obviously, if all the electrons are shared, no electron is left behind. And also I told you that in covalent bond, they can't lose or gain electron, they just share electrons, so their dot doesn't conduct electricity. Hence, here all electrons are shared. You can see I have not completed the diagram obviously. So you might say iska, but when you see a complete structure of diamond, every carbon is sharing electron, no electron is left behind. और जब इलेक्ट्रॉन होगा ही नहीं तो कंडक्ट तो इलेक्ट्रिसिटी होगी नहीं, because electron is obviously needed for conduction of electricity. We have studied in our previous chapters as well. It is not something very hard, and to be honest, I don't think it's something very hard to memorize as well. Also, it's not very important, but we can't take chance in board, so you can just go through it, and you go through it once, you will remember it. Okay, just remember the word tetrahedral, something about hardest substance and doesn't conduct electricity. Here you can say that all the carbon element, all the carbon allotropes must not conduct electricity, because covalent bond electricity करते ही नहीं conduct. So I have a better argument for that, and I will tell you my argument with example. So let's go into that. Okay, फटाफट रब कर ले. Allotropes, allotropes, allotropes. Okay. Sorry. Now the okay. Now the second number is graphite. Okay. 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 So they are the 4 points about graphite. I don't know I can name 4 points or not, but okay, let me try. It's dark colored. It's uh, forms. Okay, first point I should write allotrope wala. Allotrope of carbon. I know I might taking a lot of time in writing, so sorry for that. Okay, dark colored allotrope, it conducts electricity is the point here I wanted to discuss the most. You know, my heart is just waiting for you all to tell how can this graphite can conduct electricity being a carbon allotrope. Okay, now fourth was each carbon is joined with three carbons only, forming hexagonal rings. Okay, now let me just discuss with you all the 4 points. डार्क कलर तो होता ही है, फिजिकल प्रॉपर्टी है इसकी डार्क कलर्ड. Like unlike the luster of the diamond, it is dark colored. It's not really lustrous. You can check your pencil. It is made up of graphite. The point from where you write it. Okay. It's an allotrope of carbon. It can conduct electricity. It's a very important term. That why carbon can't conduct electricity and this graphite can conduct electricity. And mind, this question can come in your examination that why graphite conducts electricity and diamond doesn't conduct electricity. So diamond doesn't conduct electricity because it doesn't have any free electrons. Free electrons है ही नहीं तो नहीं करते conduct. और इस point का answer यहाँ है. Each carbon is joined with 3 carbon only, form and form hexagonal rings. Now, if you want to know about his structure, just refer to your NCERT textbook. I think it's in the starting of the chapter itself. You can check out. It's in the yellow color, I think, box, green color box, maybe. Okay. So, each carbon is joined with 3 carbon only and forms a hexagonal rings. Quite serious topic here. Let me just try to draw it. Okay, let me just try to draw it. एक तीन 1 2 3 1 2 3 1 2 3 1 2 3 1 2 3 1 2 3. Okay, this kind of structure is what basically it forms. Now I know it must be confusing and मेरी drawing से तो obviously, but just manage with it. Okay, so you can see it's forming something like hexagonal rings, right? And if you focus, each carbon is only sharing 3 electrons. तीन सिंगल कोवलेंट बॉन्ड ही बना रहा है एक कार्बन. It is only sharing 3 electrons and it is only joining with 3 carbons. One carbon is only joining with 3 carbons. तो इसमें answer, can you think of it that why it can conduct electricity? Fast. If you can, just comment below. You must have figured out how. So each carbon is left behind with 1 electron. एक इलेक्ट्रॉन जो शेयर नहीं हुआ, I can call that one electron as a free electron. Hence, the free electrons of this structure of the graphite is actually helping out in the conduction of electricity. ठीक है, let me just tell. ये एक कार्बन 1 2 3 तीन सिंगल कोवलेंट बॉन्ड ही बना रहा है and with only joining with 3 carbons. Obviously तीन सिंगल कोवलेंट बॉन्ड मतलब 3 कार्बन ही हुआ, मतलब इसका एक इलेक्ट्रॉन फ्री है इस वाले के पास. सिमिलरली इसके पास भी होगा, इसके पास भी होगा, इसके पास भी होगा, इसके पास भी होगा, सबके पास उसी तरीके से होगा. सो ये सारे इलेक्ट्रॉन्स एक्चुअली हेल्प इन कंडक्शन ऑफ इलेक्ट्रिसिटी. ठीक है. सो द रीजन बिहाइंड व्हाई ग्रेफाइट कैन कंडक्ट इलेक्ट्रिसिटी इज बिकॉज each carbon is joined with 3 carbon only, forming a hexagonal rings, and the free electrons help in conduction of electricity. As simple as it is. वो तो ठीक है. अब आगे एक और इसमें बात थी that I think I missed out. It is that, let me just rub it. Let me just rub the whole thing. Please refer for the diagram in the book because वो वाला diagram जो मैं अभी explain करना चाह रही हूँ, it is quite difficult to draw here. Okay? It is slippery. It's slippery. Now ये point थोड़ा weird लग रहा होगा that how can an allotrope carbon is slippery. Let's suppose this is your pencil, this is my page. When you write, do you really have to struggle or lot? Now, I'm not saying that you are not doing any work writing. It is obviously a hard work to do, but you don't really have to exert a pressure with your whole hand to just move it. Like, if you have to move a rock, how hard it is, right? It is really very hard. But while writing, you can smoothly write. So it is because it's slippery. Now, again, here we are going in detail why it is slippery. Why it is slippery. So actually, the hexagonal rings, the one I had just used them, are stacked one above another. It's the hexagonal rings are stacked one above the another. Wait a second. The hexagonal rings are stacked one above another, and it can easily slide. Please mind, this is very important. It can come in examination. One more point. It's soft substance. Like obviously it is solid, so you cannot just change its shape and size by just exerting a pressure, but still it is soft. Like my cloth, it is soft. In the same way, the graphite is quite soft. I'm not comparing my clothes with the graphite. I'm just giving an example. Why it is soft? It is soft due to sheet-like structure. Now again, you will say, what do I mean by this sheet-like structure? So ये sheet-like structure वही जो हमने अभी hexagonal rings बनाए, something like this. कार्बन 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 कार्बन, इसी तरीके का कुछ था। ये पतला सा सीट लाइक स्ट्रक्चर, इससे भी पतला बनता है। मैं तो थोड़ा सा माय ड्राइंग सो इट इज एक्चुअली अ सीट लाइक स्ट्रक्चर स्टैक्ड वन अबव द अनदर। उसकी वजह से स्लाइड होता था, स्लिपरी है, and due to that sheet like structure only it is soft substance. This is all about graphite. Okay, this is all about graphite. Now the third and last allotrope. In this chapter we are going to learn three allotropes, as I told you in this beginning only. By the way, if you haven't noticed my smile, just notice it and subscribe it at least if you are liking it. Third is Buckminster fluorine. Solid at room temperature. It's a man-made allotrope. Rest were natural allotropes, but it is man-made allotrope, means it is made in laboratories. It's man-made and it is made up of 20 hexagons and 12 pentagons. 12 hexagons and 20 hexagons and 12 pentagons, and its football structure. As you can refer again and again, I'm saying the same things. You can just check out the diagram in your textbooks. Buckminster fluorines, very recently found, not very recently, but still you can say recently found. Diamond or graphite के तो बाद ही मिला है. It is solid at room temperature. It is dark solid at room temperature actually. It is a man-made allotrope, nothing natural. It is made up of 20 hexagons and 12 pentagons. 20 hexagons and 12 pentagons. And it seems to be like a football. With this structure, with 20 hexagons and 12 pentagons, it actually looks like a football in structure. In the textbook also, it is very hard to draw, so I'll not even try it. So third, Buckminster fluorines. These are the topics. Nothing more explained. इसमें ये भी नहीं दे रखा है book में that whether it conducts electricity or not. So we are not going to really dig into that. For class 10th, we are done with Buckminster fluorines and these allotropes. Now let us move to the next topic. Okay. Just a second, one more thing. C60 मतलब ये 60 कार्बन से बना है. ओके, ये काम तो रेड पेन से करना था. C60 मीन्स ये 60 कार्बन से बना है, 12 हेक्सागन से, 20 हेक्सागन है, 12 पेंटागन से, मैन मेड है, सॉलिड है. ये है हमारा बकमिंस्टर फ्लोरेंस. एंड विद दिस वी आर डन with this allotropes. In the next video, we are going to learn more about this carbon and its compounds. Till then, subscribe if you haven't done it yet. Like the video. Share it with your friends. Okay, so I hope you like my video. If you do, so like, subscribe and share my channel. Also, don't forget to ring the bell hang button so you will get all the notifications of my channel. I hope you liked it. Keep studying. I'll be back with the new video very soon. Till then, bye-bye and have a great day ahead.